Good morning, everyone. We're going to start in just a couple of minutes, having a little delay, but we'll get started. If you want to sit down here on the left side, we won't call you goats. If y'all want to come around to the front, you'll hear a lot better. It'll probably be a better experience for you. But it's so good to have you all here, and we'll get started in just a couple of minutes. Thank you. Good morning once again. So good to have you with us today. I know we have lots of visitors with us, and we'd love to get to know you a little bit better. And do we have that original welcome screen before this with the QR code on it?
I'm not sure.
Okay, that's all right. That's all right. Yeah. So if you are visiting with us, you can fill out a visitor's card, and if you'll leave it with me or put it at the welcome desk out in the foyer, that would be great. We appreciate that. But we're really happy to continue our God and Science seminar this morning. We started last night, and we had a great lesson from our guest speaker, Mike. Mike Houts is a NASA scientist, and he is an MIT graduate, PhD, and he's got the science background, let me tell you. And he's associated with Apologetics Press. Many of you are familiar with that Christian Evidence website that really is there in defense of New Testament Christianity. And what we're trying to do, of course, is to spread the gospel of Christ and to uphold the truth of the scriptures and turn people to God and to salvation. And I just heard, Mike, some things about you last night, how you like to go around the world and do some mission efforts as well. And we really appreciate that heart for the Lord and for souls. And of course, if there's anyone here that likes to know more about the Lord, about His church, about salvation, those kind of things, we'd love to visit with you some more about that. We want to encourage everyone in every way that we can. Try to help each other, help everybody get to heaven. And ultimately, that's what everything we're doing is really about. But Mike did a great job in showing us how that science supports the truth of the Bible, how it is opposed to evolutionary theory and atheism and those kind of things. And so I think you'll really enjoy what he has for us today as well. We'll be meeting here from 10 until 12, and then we'll have a lunch in our annex across the way. Everybody's invited to be our guest for that. We'll have a little Q&A session afterwards, and I know Mike will be able to be around and to answer whatever questions you might have. He'd love to visit with you some more as well. So we're going to begin with a word of prayer. Lane Lanier, who has been visiting with us for a good while, and he's here with us this morning. I've asked him to come and lead us in that prayer.
Let's bow. Heavenly Father, we come before you humbled. You are great and mighty. And you are so intelligent. You make the wisdom of men foolishness. And we have seen that on display over the last 24 hours. The schemes of men will never cease until you come. Equip us, O God, with knowledge and with courage to stand firm in your word so that we can be ready to give an account for the hope that we have within you, and to do so with meekness and fear. Lord, help us love you with all of our heart, our soul, and our mind and strength. Lord, we ask a blessing upon everyone here, that we can put away the distractions of the world and focus in on things that will help us be soul winners for you. Help our minds to be active and ready to learn today. God, we pray that in our own studies that you help us to be aggressive and intentional in the way we approach you and your word. We are so thankful for Jesus Christ. We are so grateful for his death, the blood that was shed that covers our sins, and we are so grateful for the resurrection that provides us hope of spending eternity with you. We ask a blessing upon our speaker today, that you will be with him, that you will help him to recall the things that he has studied, and that he can convey those in a way where we may understand. Above all else, Lord, may you be glorified. It's through Jesus' name that we pray. Amen.
Well, good morning. I'd like to thank everyone for being here again. We had a great session last night. Really appreciated just all the interactions and everything we got to talk about both during the session and after the session. What we're going to be talking about today is the origin of the universe. And before we start, I want to go ahead and just do a kind of a quick review about what we talked about last night. So the first thing we talked about, was the, let's see, let me go ahead. Okay, yeah, there we go. Yeah, so during that session, you talked about the most important decision we ever make is where to put our faith. And so that was really the first point, that the only way we can make even simple choices is because God has given us a soul. If God had not given us a soul, we would just be a very complicated chemical reaction. Chemical reactions, no matter how complicated, they can't make choices. A piece of wood can't choose where or how it's going to burn. It's just a chemical reaction. It just depends on things like temperature, concentration of atoms, pH. But again, no choice. And so we say, the most important choice God gives us. We all got to choose to come here this morning. Really appreciate that. Got to choose where you're going to sit. But by far the most important decision any of us ever make is where we're going to put our faith. And so maybe a way to think about that was the fact that we can choose tells us how we should choose. And so in other words, since it's God that gave us a soul that allows us to make a choice, because again, without a soul, we're just a bunch of chemicals reacting. Because God gave us the ability to make choices, why would we choose to do anything except God's will? And of course, that's where we go to the Bible and say, well, what does God want us to do? How does he want to live our lives on earth? How do we accept the free gift of salvation? And it's when we were talking about examples in Acts where people, they hear, they believe, they repent, they confess, they're baptized, they remain faithful. All very clear from just examples, but many other scriptures as well. And so, but again, that's the most important decision we ever make. And so then the other point is when we're making decisions, we need to stay focused on eternity. Because you think about it, physically, there's a lot of really important decisions we make in life. I mean, everything from, decisions you're making in high school about what education you want, maybe after high school, deciding on who you want to marry, how we want to lead our lives. I mean, so all big, do we have a family? Really important decisions in life. But we also need to stay focused on eternity, because a really long life on earth, say 100 years, that's still zero compared to eternity. In other words, if we think of eternity as an infinite number of years, really long life on earth is still zero compared to eternity. I was talking with a young man last night and just mentioned he has a friend that's struggling with cancer, and boy, that's really hard, especially at a young age. And just how do you talk to someone about their eternity? One of the things is just like, if you want to kind of keep it lighthearted going into it, just say, well, maybe we'll both beat Methuselah. We'll make it to be 970 years. Okay, well, even 970 years is still zero compared to eternity. And so try to encourage people to focus on that, not the struggles of this life, not what they might be going here, but really just studying the scriptures and really making sure that they're focused not only on their own eternity, but of course the eternity of others. And that's why we're, again, supposed to go into all the world and preach the gospel. It makes our lives really good on earth. Christian life is the best life you can have. But it's also, allows us to spend eternity with God in heaven. And so that's the importance there. Then we've gotten a little more technical arguments. Just this one alone, just the idea that life could somehow make itself. I mean, it's scientifically absurd. I mean, it's worse than saying an airplane could make itself or this computer could make itself. Had a teacher to come up last night. She had some great examples about how you even point out to second graders that, hey, life can't make itself. And so, but many ways you can go at that. You get into the biochemistry, and there's some books back on the back table that'll be here at the congregation if you really want to get deep in the biochemistry. But just thinking about it, we spend hundreds of billions of dollars on biotechnologies. Really smart people working in that area, smartest PhDs, incredibly sophisticated laboratories. No one's ever come close to making life without using living material to start with. And so to say that, nowhere close. So to say that life just made itself, well, that's worse than saying a jet airplane makes itself. With the point being that God has given us the creativity, intelligence to make things like jet airplanes. Nowhere close to making life. And even again, so that's when we talked about. Because I don't want to get into that too much because I'll just keep talking. And then the other one that we noticed was when you look at mutations and natural selection, what we're observing is that information is being lost from the genome, not added. And we'll talk about this more during the Bible class tomorrow morning. But there's studies out there now saying we're actually losing 1% to 5% fitness per generation. And that is huge when you think about that. And the reason we're going to talk about it in Bible studies, you think of the societal implications there. If you're losing 1% to 5% fitness per generation, well, as Christians, that's just part of, you want to learn about, know about societies and cultures and people's backgrounds, and that's how you evangelize. That's how you preach the gospel. It makes it much more effective. So it's important to know that. But our focus is on the spiritual. Our focus is on eternity. But boy, can you imagine if someone doesn't believe in God, if they're purely about the physical, they somehow think that the physical is all there is, well, they can have a completely different response. And so one of the things that's unfortunately happening is there's almost like a rise in eugenics again. And this is partly what's driven it by it. So we'll talk about that more tomorrow, but so it's not just hey, evolution doesn't work because we've studied mutations and natural selection and you don't add information to the genome. In other words, you're not adding the genetic information needed to turn a bacteria into a person. I mean, that's important right there because it's just one more reason that we know evolution isn't a scientific theory. It does not work. But it's also important because of the societal implications that's starting to have now, and it's probably going to keep getting more serious over the next few years. And then I think we finished up last night with just the fossil record. It's more consistent with biblical creation, where that fossil record was laid down primarily during the flood. All the different effects you'd have, the evidence is there. Much more consistent than it is with the idea of evolution. Okay, so what we're then going to just quick review to talk about some of the scripture that we had talked about. But one that we don't think we mentioned last night is always remember, we want to speak the truth in love. And one way it's easy to keep ourselves calibrated on speaking the truth in love is to remember our struggle is not against people. I mean, I can be talking to a person that's really opposed to what I'm saying, and they're kind of irritated, but it's not, so it's easy to kind of not keep the same tone that we should keep. But again, it's all situations speak the truth in love. Ephesians 6:11 through 12. Put on the full armor of God so that you'll be able to stand firm against the schemes of the devil. For our struggle is not against flesh and blood, but against the rulers, against the powers, against the world forces of this darkness, against the spiritual forces of wickedness in the heavenly places. And so the sermon tomorrow, we're going to basically talk about the victims of our enemy. And what I mean by that is, there's some just really obvious things, if you stand back and look at them objectively, that very intelligent people will be completely deceived about. And I'll just go back to the idea that life could just make itself. Really intelligent people are still clinging to this idea that, well, maybe life made itself. And the scientific evidence against it just keeps piling up. And so it's again, I would just say they've just been deceived. And that's, I'll just call them a victim. And so we need to keep that in mind when we're talking to them, because it can get so frustrating. It'd be like if, again, if you were, use the example, if you were out at the airport and you went up to the gate agency and started complaining about the ticket price, because we all know that the airplanes just make themselves. And no matter what the gate agent said, you just kept arguing. Well, eventually he or she's going to get frustrated. Don't blame them, But deep down, they got to be thinking either this person's completely insane or they really, really deceived, So anyway, but that's what we need to avoid, because again, our struggle is not against people. So I'm going to start out. We did this with the origin of life last night. That was Ernst Haeckel's book, History of Creation. So I'm going to start applying it now to life in the universe. And so again, what we did, if you remember, we went back, his book was published in 1876, and we just showed what he had claimed in his book as kind of more like what he had hoped to be true, because he was trying to be an atheist, trying to show life could make itself. So he was trying to show this real simple life. So that was about 1876. Well, this was kind of simmering at the same time, but I'm going to start at 1907, because this is the idea that there's intelligent human life on Mars. And so end of 1907, Wall Street Journal, anybody hear of the Wall Street Journal? Yeah, I mean, it's actually probably still considered the most credible newspaper in the U.S., or one of the most credible newspapers in the U.S. Okay, so, it's the end of the year, and it's always, okay, what were the big stories of the year? We had I think Time does the person of the year. Everybody's got there, what were the big events of the year? Well, this was there. It says, at the end of 1907, the Wall Street Journal reported that the most extraordinary event of the past 12 months was the proof afforded by astronomical observation that conscious, intelligent human life exists upon the planet Mars. I'm not, well, that is pretty big. I'd go along with that. Probably nothing bigger happened in 1907. And so, but again, this was their cover story, or their story of the year. And it kept getting reinforced. So that was 1907. 1915, this was the edition of the American Museum Journal, so that's published by the American Museum of Natural History in New York. Again, real, big, credible scientific organization. They're doing studies on this, and so they kept reinforcing this idea. So it wasn't just the Wall Street Journal said it, everybody laughed and moved on. No, it kept getting pushed and pushed. And so this was, talked about Percival Lowell. It says, Dr. Lowell believes that the numerous line-like markings seen there are those of vegetation growing by an enforcedly constructed irrigation system. And so that, again, eloquently worded, it's basically just saying that they're having to irrigate to get the crops to grow there. Two significant facets found by observation support this theory. His theory. First, the marked geometric directness of the lines. No natural causes can account for them. Okay, so you hear that a lot. Someone will find a meteor and they'll say, oh, we saw this and this in the meteor, and then they'll claim, oh, no natural cause could do that. So it must have been proved that there was life on that meteor. And then usually within like 3 days, you got like 20 people saying, no, it could have been this, could have been this, could have been this, could have been this. And so, so that it's interesting, that same, I'll call it like peer pressure. There's no natural cause that could do this. So they're using this to prove the human life. And then second, the characteristic manner in which they develop with the seasons and the melting of the snow caps. Okay, that was basically either just made up or an optical illusion, based maybe on dust storms or other things. But anyway, so again, but published by the American Museum of Natural History in New York. So people will say, well, do you have peer-reviewed? And what's great is, creationists have a ton of peer-reviewed material now. It's available. A lot of times people just look at the peer-reviewed secular literature and look, again, for scientists speaking as scientists. You make a really strong case for creation. But the other thing you have to remember on peer review is sometimes it's complete nonsense, because this would have been one of the most respected magazines around at that time, or most inspected journal around at that time. And again, completely off, but it's really convincing the way it's worded. Goes on, then you start thinking about, okay, say you were I'll say a college student, because college students get hit with this a lot. And so you're sitting in class at college, and someone comes in and puts the Wall Street Journal down in front of you and says, hey, what do you think of this? First of all, it'd be kind of fascinating. You just kind of, I haven't heard that before. Give me some time, I'll read the article. That'd be a good way to respond. I mean, you want to engage with people. But then, you start thinking about all the reasons that, hey, this probably doesn't sound right, doesn't sound biblical, maybe it's not true. Well, how are you going to disagree with them? You're the student, if you might have professors calling you names, telling you don't know anything yet, especially if they're trying to convince you to be an atheist. But here's Percival Lowell. Okay, he's the one that was pushing this. He's a Harvard University graduate, fellow of the American Academy of Arts and Sciences, very wealthy. He had sent a well-equipped team of engineers and astronomers to the Atacama Desert in 1907 to observe canals. Okay, now this should be a clue right away. We talked about this last night, where people were paid to find evidence that dinosaurs turned into birds, and so that really skews the evidence you'll get. Well, they were paid to go to the Atacama Desert to observe canals. Atacama Desert is probably one of the best places to stargaze. I mean, the air is really dry, you can get up pretty high. So if you're on that team, and the guy that paid for your ticket and gave you like some of the best astronomical equipment available that day to observe with, and you're there, and he just wants you to look for canals on Mars. I mean, again, it's human nature. I'm not even saying it's bad. It's just, man, I'm going to do my best to find canals on Mars for him. But that's unfortunate. It's going to skew your observations. And so, but then there was others, the French Academy of Sciences. They actually considered the Martian civilization a fact, and apparently they were offering a reward for anybody that could prove there was other civilizations in the universe, except for the one on Mars, because they already knew there was one on Mars. But if you could find a civilization somewhere else, you're going to get pretty healthy reward. And then again, many influential people believe in evolution. Life is expected to be common throughout the solar system. And so again, this is going on for years. I mean, we're talking was 8 years from the Wall Street Journal article to that article published in the very respected journal. And so went on for many years. Now, but the question would be then, okay, if the Wall Street Journal was correct, what would have been some of the biblical implications? And so you can think of a lot of them, because that's another tendency we might have is, very reputable newspaper just sent this article. It's strengthened by this very reputable journal. So, okay, so how do I fit that into the Bible? And that's a temptation that we find that all day, and so we have to, but if you start thinking about it, there'd be all kinds of biblical implications for this. So, you could just say, well, why did Jesus come to earth to die if God also created humans on Mars? Okay. Are Martian humans sinless? Okay. But, that could be an answer. But if they are sinless, then why are they going to be destroyed with the rest of the universe? Right? And then you get, well, why didn't God tell us He created humans on Mars? Because that means if we just figured out that there's a civilization of people on Mars and God didn't tell us, that seems kind of odd, because the Bible tells us it has everything we need, to be perfect and complete, which is true. And so that covers it. And then another one's kind of interesting. There were 1,656 years between creation and the flood. Everybody was smarter because Adam and Eve were created perfect, and so their brains were better. Everybody spoke the same language. People lived a long time. I mean, if you look at those lifespans, it would be the same as saying Isaac Newton could have brainstormed with Albert Einstein. And so you really don't know what technology they had before the flood. And that technology, of course, all trace of it would have been destroyed by the flood. You really don't know what kind of technology they might have had. So the question always comes up, well, what if they had the technology to go to Mars? And so, and again, your all of our evolutionary indoctrination, say, they were primitive. But you step back and think about it. No, they might have, there's only been, 600 years since we invented the printing press? I mean, they had 1,656 years. Who knows what technology they had? So could people from before the pre-flood world, could they have somehow gotten themselves to Mars? Okay, well, you'd say maybe, but if they did, then does that mean that with the brain power that God has given us, which is really ironic, would somehow let us escape the judgment of God. And so that opens up a can of worms. So we have to be really careful, because there are going to be things that, come out, and they really are biblically consistent, and we just haven't thought about them before. So I'm not saying that everything new that comes out is wrong, but it's just we really have to think hard before we instantly accept things, no matter what the source is, to make sure that it's not contradicting the Bible, because we know the Bible is God's inerrant word. And so anyway, you kind of know the rest of the story here. 1950s, it's starting to fade a little bit, but that's 50 years after the Wall Street Journal article. But you still had magazines, great Disney videos out on YouTube, just about what alien life might look like, and talking about are we gonna, when we get to Mars, are we gonna find people, or are we just gonna find like rabbits and grass and plants? And those were the only two options, right? And so then bummer. True Science advanced. We sent an orbiter to Mars, Mariner 4, 1965. Got some pretty good pictures. That's not necessarily you could get more data from that first picture than might appear. Wow, it doesn't look like there's a whole lot there. 1976, we land on Mars. Those pictures taken in 1978. Wow. There's definitely probably not people there. And of course the atmosphere we figured out is way too thin. It's like less than 100th the atmospheric pressure on Earth, so you can't live there anyway. And then we had a helicopter flying around. It was actually a really successful mission. The Perseverance rover engineered helicopter, that was pictures taken in 2021. So, there's nothing on Mars. We've looked there where we find, you find even just the simplest of things, and it's still, maybe this is evidence, maybe that's evidence. We are finding a lot of evidence that Mars isn't 4.5 billion years old, just by the presence of water in certain locations and other factors, but it's but no evidence at all of life. And so again, I would say it was fully disproven in 1965, but that's 6 decades. So we want to, again, you keep our faith in the Bible. True science is advancing. True science is catching up with the Bible. But boy, 60 years, that'd be a long time to wait, and so it's, so again, just an example. Now, okay, so that's this life on Mars. So we've totally debunked the accepted idea that there's a human civilization on Mars, and basically we know there's not even a bacteria on Mars. There's just nothing, and that's going to actually be important for certain things, like if we want to send humans to Mars. It's important that we establish that, because otherwise, I won't have time we can talk about that at lunch or something, but it opens up a whole can of worms if we keep pretending that maybe somehow there's a bacteria on Mars somewhere. Anyway, so that was Mars. So then the next, let's see, might have had a repeat there. Okay, so the next question are we alone in the universe? Okay, because now we figure out, okay, there's no civilization on Mars, but are we alone in the universe? And so that's also come a long way. This is from an Oxford University study in 2018. And basically what happened was we've had enough observations, enough satellites, enough data come in, and if there were other civilizations in the universe, we should have detected them by now. And so they went ahead and did a study, and didn't want to just say, hey, we were just way off for decades and we should have known better. So what they did is they did a study, and they just kind of took an objective look, pretty objective look. Again, this is a totally secular university. Says, when we take account of realistic uncertainty, replacing point estimates by probability distributions that reflect current scientific understanding, okay, then we find no reason to be highly confident that the galaxy or observable universe contains other civilizations. Okay, so that's huge. You don't, because we all grew up, or at least I grew up, boy, science fiction movies, we just need a fast enough spaceship, figure out warp drive, something, we're gonna find civilizations all over the place. That was just generally accepted. Now they're saying there's no reason to be highly confident the galaxy or even the observable universe contains other civilizations, and thus no longer find our observations in conflict with our prior probabilities. And so what they're really saying is they went back, they looked at some things a little deeper, and they figured out, even though they used to say there were civilizations all over the place, now they're realizing that there's not. Goes on. Let's see. Goes on and says, we found quantitatively, sorry, there's just a little lag there, let me go back. We found quantitatively similar results through 2 different methods, using the author's assessments of current scientific knowledge bearing on key parameters, and using the divergent estimates of these parameters in the astrobiological literature as a proxy for current scientific uncertainty. Okay, so that's good. They're just saying what they did. But here's the numbers. And so this is pretty impressive. It says, when we update this prior in light of the Fermi observation, and I should mention that Enrico Fermi, he was a very famous scientist. He worked on the Manhattan Project, and he had observed, I think it was 1950. It was just almost like a lunchtime conversation, and he just said, where are they? And of course, everybody knew what he was talking about just because of his interest. Even in 1950, he was saying, hey, if there were other civilizations out there, we should have detected something by now. And of course, we hadn't. But anyway, so that's the Fermi observation. It says, we find a substantial probability that we are alone in our galaxy and perhaps even our observable universe. So again, these are totally secular, very secular institution. Say up to 99.6% chance that we're alone in the galaxy. And they're saying, in their mind, up to 85% alone in the universe. Now, of course, we would say it's easily up to 100%. In fact, biblically, it's, can't really find a way that there would be other civilizations in the galaxy or the universe, from the Bible, at least. And then it says, where are they? Which was Fermi's observation. Probably extremely far away and quite possibly beyond the cosmological horizon and forever unreachable. So think about where you've gone. You've gone from 1907, where we know there's a story of the year, there's a civilization on Mars, and then you had journal articles reinforcing that, saying, oh, we observed this, this, and this, and this, and there's no natural explanation for that. So, evident to not only do we know that there's no life on Mars, but now we're starting to say that, hey, we're probably alone in the galaxy and the universe. And so that's so again, true science is advancing, and then of course, when we think about it, that's completely consistent with the Bible. Genesis 1:26-27. Then God said, "Let us make man in our image, according to our likeness, and let them rule over the fish of the sea, and over the birds of the sky, and over the cattle, and over all the earth, and over every creeping thing that creeps on the earth." God created man in his own image, in the image of God he created him, male and female he created them. And so again, alone in the galaxy, alone in the universe, completely consistent with the Bible. And that's why I say true science is catching up. So rather than, oh, wow, how do we explain that civilization on Mars, which would have been, 120-ish almost years ago now, hey, true science has caught up, and they're saying, hey, we might be able, probably we're alone in the galaxy and the observable universe. Okay, so then it goes back to, okay, well, even if we are alone in the universe, well, how did the universe get here? What was the creation of the universe? And so for a long time, I just call them standard billions of years theories, and the idea was maybe, the universe is expanding, and it's expanding at an accelerating rate. And we'll talk about that later, but that's a huge issue for the Big Bang, because it'd be like if you threw a ball in the air, and rather than the ball decelerating and falling back to the ground, it started to accelerate away from you. You'd be like, wow, there's something weird going on, and so that's basically when the universe is expanding at an accelerating rate, and that's why we've had to make up this idea of dark energy, somehow, and we have absolutely no idea what it is, what it could be. It has to fit the Big Bang Theory. There's actually biblically consistent theories. We'll talk about one that actually get rid of the need for dark energy. So that's huge. I mean, that should be Nobel Prize winning. It's actually, some of the theories are actually rejected because they are biblically consistent. But just think about that. If you threw a ball in the air and it started accelerating away from you, I mean, you could just say, oh, there must be this mysterious force in the church building here that's causing that, and we could call it dark energy, and that's basically what the Big Bang's doing. But no, let's get back to reality, see what's really happening, and those are the biblically consistent theories. We'll talk about those in a few minutes. But anyway, the problems with the standard billions of years theories, I was recognized as early as 1933, and in the 1970s, we had enough observational evidence that had to do something about it. And so I was always really interested in science and space and engineering, and so I actually remember a little bit of this debate because they're trying to work on this theory of the universe, but they were going to introduce basically, some people call them adjustable parameters. They're really just fudge factors, but just something to pretend that our observations were still supporting this theory. And so at the time, they were going to say that, hey, we're going to have to make up 50% of the universe. Okay, so just to make our theory work, we got to make up 50% of the universe. And so, and of course, you can see there's a debate. Now, if you got to make up 50% of the universe, there's something wrong with your theory. You need to come up with a better theory. But then the counter was, well, no, we just need that so we can kind of establish a framework. Well, unfortunately, a framework can be very constraining, and so that even further reduces the probability they're going to come up with the real answer. And so we're going to just have this framework, and we need to make up that 50%. And so, but it'll get lower. Once we have that and we start working the framework, it'll get lower. Well, the opposite happened. It actually got much worse. The more observations came in, not only did they have to make up 50% of the universe, now they have to make up 96% of the universe. Okay, so just think about this theory that you'll get, people, eloquent, intelligent atheists pounding their fists on the table. The Big Bang is a proven scientific fact. It's just like the law of gravity. You get people, they're making up 96% of the universe. I don't even know how they do that with a straight face, but they do. And so that's kind of where we're at. And so now this was a quote from NASA Administrator Mike Griffin. He's an administrator. This was a speech he gave in 2007, former NASA Administrator. He said, "What is the value of discovering that literally 95% of the universe consists of dark energy or dark matter, terms for things as we as yet know nothing about, but they make up 95% of the universe?" Okay, so that's, and so I emailed him, and he was really hardworking, really dedicated. So, and so it was like I sent him an email like at midnight, and I don't usually work till midnight. I just happened to be working late one night, and and I'm like, well, he'll never answer. He's the administrator, I'm whatever, and literally, so I finished a couple things up, started packing up. By 12:30 a.m., he had responded. Okay, and so and he's again really smart guy. Great, tremendous contributions to our country. But he basically, he just thought it'd be a quick answer. He goes, well, it has to, because the Big Bang doesn't work if dark matter and dark energy aren't there. And he thought I just wasn't aware of that. So I said, so go back and forth. I was like, well, what if the Big Bang isn't true? And then he responded, stayed real cordial. But the bottom line was he basically came down to, he understood I was putting my faith in God, and there was something, we might not know exactly how God created the universe, but God had, and he was thinking that, well, we'll solve these problems with the Big Bang eventually. And so, but I'll just mention that many reasons, the biggest one is don't be afraid to talk to anybody, because I didn't get my pink slip the next morning. I mean, he was fine with it. So it's talk about the subject, try to get people thinking, and I was able to interact with him. Haven't seen him in a few years, but we had a good professional relationship from there on out. So don't again, just never be bashful about talking to anybody. But the whole point was, you'll see these quotes, and by the way, I should mention also his speech was, a lot of times people say, why are we spending all this money on space, when we got these problems on Earth? Well, it's because we don't know anything about the universe. Yeah, I agree so much with that, so it's not, but this was just the one particular example he started using, because we're going to learn a lot through space exploration. But anyway, so that was his quote. And then you look at just some others. This was actually in Scientific American. This was way over 20 years ago, but the same's still true today. It's actually gotten worse. Some of the ideas they have to pursue, they've been pursued and they've been shown to be dead ends. It says, it has been noted that the names dark matter and dark energy serve mainly as expressions of our ignorance, much as the marking for early maps with terra incognita. Okay, that's a true statement. We're just ignorant, so we have to make some stuff up, And it says, current evidence favors models in which primary component of dark matter is new elementary particles collectively called non-baryonic dark matter. That's pretty much been rejected. But again, this was what they were pursuing at that time. And I like this last quote, dark energy considered even stranger. The only thing we know about dark energy is its name. And again, I talk about people writing eloquently. I love people when they write eloquently. I thought that was just a great way of saying that we were just making this up. You make up, it's like Tinkerbell. The only thing we really know about Tinkerbell, well, we knew her name, but I guess they had a few other things in the movie, but or the cartoon. But they're basically saying the same thing about dark energy, which is true. And so where we're at now, you have dark matter and dark energy distributed anywhere throughout the universe in any fashion desired. They can have any property desired. If that's not enough, you can have what they call dark flow, dark light. You have inflation that's been introduced. So you think about it, if you have that approach, you can use that approach to support really just any theory desired. Okay, so I was talking to Curtis last night, and he thought, one thing you could do to really spruce up your talk would be to get some more math in there. Okay, and I should have known that. I mean, people like math. I mean, if you're come to a Friday night talk, you expect some math. And so, here's our math problem for this morning. But keep it simple. It's Saturday morning. So what we're going to do is I want you to give me an answer to this equation, but you cannot use algebra. okay? Because I know a lot of you guys have had some advanced math. Okay, so you're not allowed to use algebra. So if x plus y equals 100, what does x equal? And you can't use algebra. I think I heard 17. I'm not sure if I did or not, but 17. You are absolutely right, whoever said that. X is 17, y is 83. X plus y is 100. Anyone else want to try? Yes, at 21. Okay, 21. Absolutely right. X is 21, y is 79. The answer is 100. Okay, so see, this was easy. And so the point is, it doesn't matter what value someone picks for x, because y is your adjustable parameters. I can make that equation equal 100 no matter what. Now, it gets even better because, say I come back in a few years and we're talking again. We're kind of long ago, but I say, guys, I got some really bad news. The answer was actually 200. Hey, that's great, because it's still now, x is still 17, whoever guessed that. Now I just make y 183. If x is 21, y is now 179. So I can even change the answer, and I can still have, so if x is our observations, that's our actual scientific data, and I have all these adjustable parameters, well, I can pretend any set of observations supports any theory I want. And so that's why at the start of the talk last night, we mentioned, the scientific theory has to be falsifiable. By definition, that equation is not falsifiable. And by definition, the Big Bang is not falsifiable. In other words, there's no value for x you can pick where I can't make that equal 100. And the way the Big Bang is construed, there's no observation you could make where I can't pretend that somehow that observation supports the Big Bang theory. And so Christians aren't the only ones that have noticed this. And again, this goes back to, sometimes people will be like, that's a good point, but hey, you're a Christian, so I got to be really suspicious here. We're not, again, we just want people to obey the gospel. So you're not going to do anything incorrect, when we're just, trying to address questions they might have before they'll objectively consider the Bible. But this is, these are all secular scientists. This was an open letter to the scientific community, published in New Scientist, again, about a little over 20 years ago. But what they were basically doing was they were calling out the Big Bang. And again, there's several hundred, they were professors, postdocs, national lab employees, astronomers, very, credible people. And they were just saying, hey, it's time to give up on the Big Bang theory. Now, most of them probably had a non-biblical theory that they thought we should pursue instead. So I'm not saying these are all people saying, hey, go back to the Bible. They're just saying, hey, we got to give up on the Big Bang. It's not working. It's not scientific. And so I'll go ahead and read the quote. And again, very well written, but it says, the Big Bang today relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, and dark energy are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang theory. So it's like we've been talking about. You got our observations, we have the theory, and they're not matching. And so you have to put all these adjustable parameters in. They mentioned dark matter, dark energy, inflation. It says, in no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would at the least raise serious questions about the validity of the underlying theory. And so they're saying, again, just these contradictions, it's serious, and they're being polite. Now, this one is still polite. It's not quite as polite. It says that what is more, the Big Bang theory can boast of no quantitative predictions that have subsequently been validated by observation. The successes claimed by the theory's supporters consist of its ability to retrospectively fit observations with a steadily increasing array of adjustable parameters. Okay, and so that's what's basically saying if say our value of x, in that math example, say that value of x changes, hey, I can adjust y to still make it 100. Okay, that's great, but it's kind of weak. And that's basically what they're saying is the Big Bang, all it can claim is that they've got so many adjustable parameters that it doesn't matter what the observation is, they can adjust it, to pretend that it somehow works. And then it goes, just as the old Earth-centered cosmology of Ptolemy needed layer upon layer of epicycles. Okay, so now that's kind of an insult. It is an insult, but most people, you don't use that. You don't hear that on the playground too often, And so what what they're saying is, Ptolemy had this idea that all the planets revolved and the sun all revolved around Earth. Okay, so everything revolved around Earth. Earth was the center of the solar system, and he's a Greek philosopher. Now, unfortunately, that was one idea that I think was possibly incorporated at least into some, some groups associated with the church. I'll just say that. So they didn't incorporate it. And they got the blame. It was actually Ptolemy that was pushing this, Greek philosopher. And well, you do the observations, and specifically like retrograde motions of Jupiter and Saturn, things like that. You work it out. You say, okay, no, everything's not revolving around the Earth. And so rather than just making plenty of observations to say this isn't what's happening, they started adding what they called epicycles. And so an epicycle would be, what they're saying here is, and they're right, is just very analogous to like dark matter, dark energy inflation. You're just, this doesn't work. Rather than just saying it doesn't work, we're going to make up some stuff. We're going to add this, 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 and this. And so that's what they're saying here. But again, these are just, hundreds of secular, people that were working in this area. So that was, so again, just kind of interesting. You get that quote too. And so, so then you say, okay, if you're talking about some of this stuff, say, okay, well, what do you believe? And that's the question you want. So one way to start out with that is you just say, well, there's numerous biblically consistent explanations for why the universe appears the way it does. And I'm going to focus on one, and I hope I brought the DVD. It's called Light Years No Problem. I'll check and see if we have it out there. But it's just, and so it's Russ Humphreys. He's a Bible believer. He wasn't a Bible believer growing up, but he became a very well-known physicist at Sandia National Laboratory. Worked on basically physics of extreme conditions. You can picture like if you're doing essentially weapons physics, you have to be really good at what the physics is in extreme conditions. And so that was, but he, from that, he had a lot of insight in some of these biblically consistent theories. So I'm going to walk through his ideas very quickly because he's the first one to say that, hey, this is just a theory. It happens to be a lot better than the Big Bang, but it's just a theory that's biblically consistent, but it could be completely wrong. And so he said all he was doing is just to show that, hey, starting with the Bible, making something that's biblically consistent, basically doing it in his spare time, you can come up with ideas that, if you look at it objectively, are frankly superior to the Big Bang Theory. So just give some of the verses he uses to back it up. It says, in the beginning, God created the heavens and the earth. The earth was without form and void, and darkness on the face of the deep, and the Spirit of God was hovering over the face of the waters. Okay, so this sounds trivial, but okay, the universe was initially composed of water, right? I mean, that's Genesis 1 and 2. Then he goes on, the other verses he was using, Genesis 1, 6 through 8. Then God said, let there be a firmament in the midst of the waters, and let it divide the waters from the waters. Thus God made the firmament and divided the waters which were under the firmament from the waters which were above the firmament, and it was so. And God called the firmament heaven, so the evening and morning were the second day. So you have waters below the firmament, then the heaven, firmament or heaven, and then the waters above the firmament, heaven. Okay, so that's Genesis 1, 6 through 8. Okay, then going on, just kind of another verse related to that. Go like Psalm 148, 3 through 4. Praise him, sun and moon. Praise him, all you stars of light. Praise him, you heavens of heavens, and you waters above the heavens. So again, they keep talking about this waters above the heavens. Or it's other places in the Bible, I should say. Okay, going to Genesis 1, 9 through 10. Then God said, let the waters under the heavens be gathered together into one place, and let the dry land appear. And it was so. Okay, so you have the waters under the heavens, dry land, gathered together, dry land appeared. God called the dry land earth, and the gathering together of the waters he called seas, and God saw that was good. So earth, it's under the heavens, okay? Then go to Genesis 1, 14 through 16. Then God said, let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons, for days and years. And let them be for lights in the firmament of the heavens to give light on the earth, and it was so. Then God made two great lights, the greater light to rule the day and the lesser light to rule the night. He made the stars also. God set them in the firmament of the heavens to give light on the earth. Okay, so the sun, moon, and stars, they're in the firmament of the heavens. And that's from Genesis 1, 14 through 16. And then finally he said, or the final verse, I should say, obviously the Bible contains a lot more, but the final verse we can think about is Genesis 1:20. Then God said, let the waters abound with an abundance of living creatures, and let birds fly above the earth across the face of the firmament of the heavens. Okay, so the atmosphere now is between the earth and the face of the firmament of the heavens, because it talks about the birds flying across. The birds aren't in outer space. They're not where the sun, moon, and stars are, but the birds are flying across the face of the firmament of the heavens. So that was Genesis 1:20. So here's what you have. Other things, you always have to have a little PowerPoint diagram for people. So this was so this is basically what those verses would say, very not to scale, but you have the earth, that was waters under the heavens, dry land gathered together, the seas. Then you have the atmosphere, birds flying across the face of the firmament. Then you have the sun, moon, and stars. That's the firmament. Then you have the waters above the firmament in heaven. And so, so then just a few other verses that he then includes. And again, I really appreciate the fact, he's just doing this all just straightforward reading of the Bible. Where does that lead us to? And so a couple others he talks about were Isaiah 40:22 is, "It is he who sits above the circle of the earth, and his inhabitants are like grasshoppers, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in." And Isaiah 42:5, "Thus says God the Lord, who created the heavens and stretched them out, who spread forth the earth and that which comes from it, who gives breath to the people on it, and spirit to those who walk on it." And so this is the gist of it. And I should say this is something, boy, we can talk about, this afternoon. I know we don't have anything officially scheduled this afternoon tonight, but we can talk about this because it's, you're basically using the forefront of what we're pretty confident in physics. And so it's basically certain aspects of general relativity, but there are aspects that we've confirmed experimentally. And so one of the things is general relativity predicts, and we have experiments to verify that gravity affects time. Okay, so in other words, we're standing here talking, and we're reasonably close to sea level. So time is actually passing more slowly here than it is on top of Mount Everest. Okay, so it's gravity affects time. It's just how God designed the universe, how the universe functions. But we can experimentally measure it. Now it's not a huge effect. In the next year, time will pass, I think it's 5 microseconds more slowly here. So 5 millionths of a second less here than on the top of Mount Everest. So it's nothing to really worry about, but there is a difference, and we've been able to measure that. And so now the Bible was written to people on earth, and so the days in Genesis 1 are earth days. Now God didn't bother in the Bible telling us, well, these were the days at sea level, and if you're at the top of the highest mountain, we don't know what the highest mountain was, obviously before the flood, you might be a microsecond different. That's not, it's just a day. So they're literally earth days. But you can actually get inside essentially what's a black hole, and viewed by an outside observer, time at the event horizon of a black hole, which is very deep in a gravity well, it actually completely stops. Okay? And so what his theory then would go on to say is, just working it through, okay, so the waters above the firmament, very massive. That could put the whole firmament inside a black hole. Okay? And so then the Earth was created day 3. It's near but outside this timeless zone. So there's normal days, day 1, day 2, day 3, normal 24-hour days on Earth, which is really important because the Bible makes it clear these are normal 24-hour days. Day 4, the sun, moon, and stars are created. Okay, so that's a lot of mass. That's kind of an understatement of the year. But if you look at the mass of the universe and how we're estimating the mass of the stars, that's huge. Well, that could put the Earth basically into the whole universe, a whole firmament, into a timeless zone. That extra mass causes it to drop into what they call a timeless zone. So now you're, okay, this is going to be very not to scale. Say the universe is this big, okay? And then you have enough mass in that you're inside this timeless zone. Well, then God stretches out the heavens. And it's something like 17 times in the Bible talks about stretching out the heavens. So you start stretching out the heavens. Well, that's actually, you're spreading things out. An analogy he uses in his video, in other words, is like a trampoline. If you put a big heavy weight in the center of the trampoline, but you started to tighten this trampoline, how that weight would start to rise back up. So that's basically an analogy he looks at. So as you're being stretched out, the outer regions of the universe, they come out of the timeless zone first. It'd be just like in the trampoline. If you started stretching it out, the depth of the fabric on the trampoline, it's rising, it's coming closer to the surface first, and then in the center, is where it comes out last. So day 4, what God could be, after he made the sun, moon, and stars, he could be stretching out the heavens, and all this, he's saying in the Bible. And then by doing that, you'd have parts of the universe coming out of this timeless zone. I'll say before Earth again, but there's no time on Earth. You wouldn't even, if you were on Earth, you would not notice any of this. It would just be, but then when the Earth came out of that timeless zone, still on day 4, normal day, because it's not even, you can't even say a moment of time. There's just like no time. Okay, in the middle of day 4, all of a sudden, sun, moon, stars appear. That would be as seen from Earth. The Bible's written to people on Earth. So that's basically his theory. Okay, so you start saying, well, how's that better than the Big Bang? Well, and I'm sorry, this is the, again, just gave the summary of verses again. I was supposed to have the graphic up, also, but that's, so basically it's what we just went through. Okay, so, well, the first one is, and this is kind of funny, this is, talk about how atheistic theories hinder scientific progress, but this is actually inadvertently very strong support from Russ Humphrey's theory. So this was completely independent, but it was in the Proceedings of the National Academies of Science. So again, so it's not, again, I'm stuck on that, but every now and then someone, when they can't answer the question themselves, they'll try to appeal to authority. Well, this is a very peer-reviewed journal, so if they want to know, is this real? I mean, this is, again, extremely respected journal. It says, mathematicians have come up with an answer Monday for the mystery of dark energy tearing the universe apart at an accelerating rate. It ain't there. Okay, now to me that's eloquently worded also, but it's very direct. So, okay, it ain't there. Blake Temple and Joe Smoller suggest that expanding waves from the Big Bang are propelling the trillions of galaxies filling the universe apart, suggests the study. Dark energy is an illusion if their equations are right. However, the only problem is that for the equations to work, we must be literally at the center of the universe, says physicist Lawrence Krauss of Arizona State University in Tempe. It doesn't seem physically relevant. Okay, so you just saw the model, and the Earth, there's the waters under the firmament, so it's near the center, probably right in that particular biblically consistent model. Why isn't that physically relevant? Well, it's because if you're an atheist, you can't have anything that looks like design at all. So all the theories have to be totally random. You have to add extra dimensions. You have to do all these things to try to somehow explain the universe as we see it, but make sure it looks totally random. And so when he says doesn't seem physically relevant, that's not a scientific statement. It's what they call the Copernican principle. It's this idea that, well, since we know there's no God, which again is silly. They should just step back and think about again, life can't make itself. They have choices. So we know there's a God. But they're not even allowed to, but it's to the point where I say it doesn't seem physically relevant. That is not at all a scientific statement. And so of course, he rejects this based on, no, we all know that it has to be random. Can't have anything that might be consistent with the Bible. So again, that's holding back science. Because when you think about it, if we're making up 74% of the universe, meaning that's how much has to be dark energy, someone figures out two things: how to get rid of the need for dark energy and the location of the Earth. That should win a Nobel, if there's ever been a Nobel Prize, that should win it, because that's huge for our cosmology, our understanding of the universe. It's just rejected out hand because, boy, that sounds, it's way too biblical. It sounds way too much like there could be God. Now it wasn't just the mathematicians, this team of physicists. This was Physical Review letters, again, very respected. If Earth and its environs are centered in a vast billion light-year long bubble, relatively free of matter, in turn surrounded by a massive dense shell of material, then gravity's tug would cause galaxies inside the void to hurtle toward the spherical concentration of mass. So there's Robert Caldwell of Dartmouth College and Albert Stebbins of the Fermi National Accelerator Laboratory in Batavia. Okay, and this is exactly the structure that Russ Humphreys came up with just based on the Bible. I mean, that's exactly the structure. You have, the firmament, Earth, everything's inside this huge, very massive outer layer. Says that process would mimic the action of dark energy. A local observer would be tricked into thinking that the universe expansion is accelerating. The article goes on to note, but that scenario violates the Copernican principle, a notion near and dear to the hearts of physicists and cosmologists, including Caldwell and Stebbins. Well, again, I don't know Caldwell and Stebbins, so hopefully they didn't take this as an insult, but they're basically saying they're committed atheists, and so there's no way they're going to consider this, even though that's where the true science is pointing them. And so again, it's just the atheistic theories hinder scientific progress. So we actually could learn so much about the universe. I'm kind of a space nut. I would love to think that God designed the universe so we can travel around it and we can explore things. Of course, as we do that, it's going to glorify God even more. It's going to bring glory to God. But if we kind of self-hinder our understanding of the universe by denying God, then to me it wouldn't be unfair if we therefore can't figure out how God designed the universe if we aren't allowed to consider theories that imply that God designed the universe. And so, so we talked about Russ Humphrey's theory, but also it's just you could have other implications that stretch out the heavens. You could have the You could have God chose to make parts of the creation mature, accelerated processes during creation weeks, new discoveries. So lots of other ways to explain this. Now, I'll get to some recent observations by the James Webb Space Telescope, which actually also support some of the theories that are being developed. But also just want to make a few observations. People go out on the internet. At least a while ago, there was very anti-Christian article. I want to say it was put on even Wikipedia, which, we get a lot of good stuff on Wikipedia, but it was claiming that we knew the age of the universe to 5 significant digits. I think it was saying it was like 13.718, and it's so, billion years now. Well, the funny thing is that the exact same day, you're having all these press releases about how we have no idea how to estimate the age of the universe. And so this came out from AP, just said the universe is looking younger every day. It seems new calculations suggest the universe could be a couple billion years younger than scientists now estimate, and even younger than suggested by two other calculations published this year that trimmed hundreds of millions of years from the age of the cosmos. The huge swings on scientists' estimates, even this new calculation could be off by billions of years, reflect different approaches to the tricky problem of figuring the universe's real age. Okay, so none of these are, they're not going to come back to the biblical timescale. But it's just funny, again, if you're, I really sympathize with students. If someone's in high school or college and they're told to research something about the Big Bang, well, of course, you see what, you start out, Wikipedia is usually a pretty good summary of what people are thinking, and they have this guy saying, we know the age to 5 significant digits, only a fool would question that, and then he's got all these, and so, oh wow, that's pretty, and then you just go to other, PhD scientists saying, hey, we can't even estimate this with a factor of a few billion years. It's important they make that step. They don't just get intimidated to think, oh no, we know so much about the age of the universe. And so, so that's the main reason to have quotes of these in mind if someone was to say, oh no, we know the age of the universe, just, 5 significant digits is actually really huge. Point out, no, we don't, and then steer them towards some of these other publications. That can be important because it helps the person realize that, no, this is just this whole Big Bang evolution thing. It's just a religion. It's just kind of a false religion of the 21st century. It really has nothing to do with, well, it's getting worse because it claims to be scientific, and boy, science is advancing. Again, it's totally rejecting that and totally becoming, catching up with the Bible. The other one is, what was there before the alleged Big Bang? Well, all explanations are metaphysical because they all have to apply to where the laws of physics either don't exist or don't apply. And so I'll give an example. When I was growing up, it was Big Bang. It was a singularity, a point of infinite density where the laws of nature don't apply. Okay, well, if the laws of nature don't apply, what is that? Well, supernatural. Right? Just by definition. So they're having to appeal to this condition where the laws of nature don't apply. But boy, as soon as I can just suspend the laws of nature, make up anything I want to, then yeah. Again, it goes back to that x plus y equals 100 thing. And so the latest, another one, and this is getting more popular. It's even a lot of the Marvel movies and stuff. It's this idea that maybe there's a multiverses. Maybe there's an infinite number of universes out there. Well, the thing is, people can refer to that as the false god of the mathematical properties of infinity. And that's kind of a mouthful, but what they're saying is, I think we used the example last night, if there's an infinite number of universes, and this is just the properties of infinity, so it's really strange, but there's an infinite number of universes, then absolutely everything is happening all the time in an infinite number of them. Okay, so when people apply to the, appeal to the multiverse, and maybe there's an infinite number of universes out there, and the reason they have to do that is they say, so somehow we're in the universe where life just happened to be able to evolve, even though we know it's impossible. Hey, absolutely anything can happen. It's the idea behind the infinite number of universes. But that's worse than Greek mythology. Because you've just totally eliminated the need for science because, hey, if something happened, well, Zeus must have wanted that to happen, or Prometheus wanted this to happen, or and the effect it's having. I was as Robert mentioned, I'm blessed to get to do a lot of mission trips. I was down talking to university in Colombia, and I will say other countries are very open to this kind of discussion. It's their university systems are frankly much more open to just good, calm discussion about topics like this, very open to that. And so, but a student asked, well, why should we talk about this? Because we know, we're just in the universe where things happen to be this way. And so maybe, I was hoping he was being facetious. It was a written question. Yeah, just kind of like joking, like, yeah, you won't believe one of these things I picked up on the internet. They're saying there's this universe generator, an infinite number of universes. And I don't know if he was or not, but you just think about how demotivating that would be. Just like, well, talk about no free will. I'm just in the universe where what's going to happen is going to happen. There's no need to really do anything, because whether I do anything or don't do anything doesn't matter. Or, So, but anyway, so that's, it's just I think that one's even going away now, though. So now, unfortunately, polls are seeing there's this rise in, I think what they call mysticism. People know there's something more than the physical world, but they're not necessarily turning to the church, and that's why, to me, the church really has to just really focus on evangelism, going on all the world and preaching the gospel, which I know the congregation here does, which is fantastic to know. So, so again, another point that could come out, and this is just a question you'll get. It's interesting. You get these from. It could be the first serious question a child asks. I mean, I'm talking like 5 years old, but it can also be the first question a person asks who's never really considered the Bible. And usually they'll say things like, well, if, God made the heavens and the earth, who made God? I mean, first verse of the Bible, in the beginning, God created the heavens and the earth. And so first verse of the Bible actually mentions that, or explains that, because in the beginning, God created the heavens and the earth. That means not only did God create the heavens and the earth, God also created time. Okay, so for God to create time, he has to be outside of time, and that, by definition, being outside of time, nothing outside the dimension of time can have either a beginning or an end. Okay, so I know it's weird to get our heads around, but you can't, words like before and after, they don't make any sense outside the dimension of time. Beginning and end don't make any sense outside the dimension of time. First verse of the Bible says, in the beginning, God created the heavens and the earth. So Bible hits it head on, first verse. The Bible doesn't make us go to things like maybe points of infinite density where laws of nature don't apply, or maybe there's an infinite number of universes out there. Because both ideas have a supernatural beginning. Bible, very first verse tells us that because God created time, he's outside of time. He can't have a beginning or an end. Well, that's supernatural. Okay. The other theories that claim to be somehow purely scientific, just the science, I put my faith in science, they all appeal to the supernatural too. And so that's just the point to make. Now, the God of the point of infinite density can't give me free will. So I can still anchor back to why I know I need to put my faith in the God of the Bible, not these other made up, technical sounding false gods. But it's just interesting that the Bible hits on the very first verse, and most of the other proponents of the other theories, they kind of dance around this. They try to get something that, get someone famous to somehow say, well, maybe scientifically this is possible, but they just, they don't address this at all. And then I'll give a strange one related to the Big Bang, and this is just, so they're saying basically the universe just made itself, okay, and it's very finely tuned, and it's so finely tuned that it allowed everything that we see happening to happen. Well, again, non-Christians, you just go back and say, okay, well, what's more likely? You don't believe in a soul in this philosophy, so it's all chemical. So what would be more likely, for a universe this finely tuned to just pop into existence, or for a brain just to pop into existence? Okay, well, the answer is it's much more likely for a brain just to pop into existence. Neither one's going to happen, but the idea is, what if this brain just pops into existence and just happens to be, chemically oriented in a way that, makes us, think we had a childhood, think we're in a building, think we're talking to each other, but we're really not. It's just this tiny fraction of a second, tiny fraction that we pop out of the chaos, and we have this brain, and we think all this stuff went on, and then, we just dissolve again. Okay, so that's called a Boltzmann brain. And you first read that, you think that's really strange. Now, again, it does have a good Hollywood heritage. Ego in, I think it's Guardians of the Galaxy, he's a Boltzmann brain. So go back, don't watch the movie just for that. But I'm just saying, okay, so at least it's got the credibility of making some cartoons. But this is actually from Wikipedia, and this is basically saying what I just said. Because again, you can go out there are people really believing this, and at least it's out there. Says, if our current level of organization, having many self-aware entities, is a result of a random fluctuation, and of course it's not a result of a random fluctuation, but they're saying if it was, it's much less likely than a level of organization which only creates standalone self-aware entities. Okay, that's a standalone brain. For every universe with the level of organization we see, there should be an enormous number of lone Boltzmann brains. So, like it's just brains, but like the phraseology, floating around in unorganized environments. In an infinite universe, the number of self-aware brains that spontaneously and randomly form out of the chaos, complete with memories of a like ours, so it's just spontaneously formed, all our memories, everything we think is going on, should vastly outnumber the brains evolved from an inconceivably rare local fluctuation the size of the observable universe. And so this is, you read other articles, they say, boy, this is a real problem. We need to study this. We need funding to study this. I mean, it's just absurd because rather than just saying, hey, there's a whole lot of evidence that this whole Big Bang thing, it doesn't work. Rather than just saying, yeah, let's try something else, it's, we need more money. We need to study this further. Because sure, you're right, this is a huge problem because no one's going to believe that they're just a brain that just happened to randomly pop out of the chaos. And so again, that's kind of where you are there. Now, true science advancing. So I'm going to talk some about the James Webb Space Telescope. Is amazing instrument, amazing it actually worked. I mean, it had something, huge number of what they call single point failures. So meaning that if any of those failed, it wouldn't work. Well, they great engineering, great design, launched, deployed, worked really well. Just a diagram of it here. But then what they were finding, though, wasn't at all what they were expecting to find. And this started coming out. There was a lot of hype about how we're going to see the Big Bang. Some people were saying we'll see regions where stars haven't formed. We'll see regions just right after the Big Bang. And then it launched, and when it first started making observations, it was just like really silent for like 2 weeks, if you notice. And then people started acknowledging that, hey, this isn't at all what we thought we'd see. It's different. And you literally went from all these claims about how they're going to maybe use it to prove the Big Bang to, not much of an overstatement. They went back to, wow, look at that really pretty picture. And that was but that's basically what happened. So a lot of assumptions about the universe changed. Again, people unfortunately aren't going back to a creation model, but it says within just the last 2 years, Big Bang theories have had to push back the estimated date for the first stars by about 150 million years, from 400 to 250 million years after the supposed Big Bang. Okay, so that's a huge adjustment because they had all these theories about how things were forming. It says now also claiming first galaxy may have formed within 200 million years of the supposed Big Bang. Other studies are saying, well, no, we just have misunderstood the age of the universe. So again, you go from just the one person that says, oh, no, we know it to 5 significant digits. There's another group now saying, well, maybe instead of 13.718 billion years old, it's 27 billion years old. Okay, so that's a huge adjustment. It's a little bit like grasping at straws because it's so destroyed again, the current set of assumptions in the Big Bang Theory, that there are people saying, still trying to call it the Big Bang Theory, but just making these huge changes to it. Now, these just came out the last couple weeks, and so this is fascinating. Again, going back to the biblically consistent theory. And I should mention, the biblically consistent theory is you don't need dark energy. So that's a 73% fudge factor. That's huge. You don't need dark matter. That's the other 23, 24, 2%. That's huge. So you get rid of all those, and the location of the Earth, which, oh, by the way, is very consistent. With that location, you get rid of the need for a fourth dimension. So, it's, so again, but this is very consistent because it says, is our universe inside a black hole? New research says it could be possible. Now, wouldn't know where we're at now so much as just what may have happened in the past. But this came out, I guess it was, May 20th. Anyway, it says, it's March 23rd, says, new research that used imaging from the James Webb Space Telescope gives credence to a scientific theory that says the Milky Way is inside of the black hole. And so that's in, that was monthly notices of the Royal Astronomical Society. Okay, so that's big. And then also detecting oxygen, because oxygen, you're supposed to have stars, you have to have whole stars form, basically develop, explode, and that's how the current theories would say you get heavy metals, or oxygen, just heavier elements. Says the detection of oxygen suggests a rapid metal enrichment during the earliest phase of galaxy formation. Again, they're still trying to tie back to the Big Bang. I'll read this quick because it's kind of detailed. But the researchers noted in the study in astronomy and astrophysics, JGS Z14-0 was found to be surprisingly metal-rich a mere 300 million years after the Big Bang. So still trying to tie back to the Big Bang. And the detection of a bright oxygen line in the galaxy underscores the notion that galaxies in the universe undergo rapid evolution. The astronomers explained in their other study in the Astrophysical Journal. Okay, so again, they're saying, hey, this all looks like it's just always been there. But they can't say that. Okay, so what they have to say is, wow, it just happened so fast, after the supposed Big Bang. I was astonished by the unexpected results because they opened a new view on the first phases of galaxy evolution, said astrophysics and paper author Stefano Carniani of the Scuola Normale Superiore in Pisa, Italy, in a statement. She added, evidence that a galaxy is already mature in the infinite universe raises questions about when and how galaxies formed. So again, you just have all these questions coming in. Now, if history repeats itself, they'll just come up with some more fudge factors, new fudge factors, adjust the current fudge factors. But at some point, it's like, I mean, all the evidence is piling up that that again, just the Big Bang's wrong. Now, again, Genesis 1:1, in the beginning, God created the heavens and the earth. Psalm 19:1, the heavens declare the glory of God, and the firmament shows his handiwork. But we all get to choose where we put our faith. Okay, so now we'll go ahead and go to the age of the earth. Okay, so that was a Big Bang, because that's an important one. A lot of people are deceived by the Big Bang. Probably at least the same number are deceived by this idea that, well, okay, we know life can't make itself. Maybe they agree that mutations and natural selection aren't causing evolution. They agree we have free will. So the idea is, okay, maybe maybe it's the age of the earth. Maybe they're stumbling on that. So first one, need to rely on the Bible. 2 Timothy 3:16 says, all Scripture is given by inspiration of God and is profitable for doctrine, for reproof, for correction, for instruction in righteousness, that the man of God may be complete, thoroughly equipped for every good work. And then John 17:17, sanctify them by your truth. Your word is truth. So we need to rely on the Bible. And also realize, though, that I guess I'm calling these strongholds for people opposed to the Bible. So they've tried to make the origin of the universe a stronghold. I think there's so much evidence against the Big Bang and actually so much evidence for the biblically consistent theories. I don't think they're going to be able to consider that a stronghold too much longer. I don't think they're going to be able to claim that, oh, the Big Bang, it's like the law of gravity. We know it's true. I don't, but that's, maybe optimism. I mean, again, the life on Mars thing held on for 6 decades. So this could be a while. But there's going to be now this stronghold of saying, well, okay, maybe we don't know everything, but we know the Bible's wrong because the Bible's clear that the Earth's about 6,000 years old, and wow, we just, you have to be so delusional if you think the Earth is that young, and that's again, famous atheists, you'll use language like that. So you could say, well, maybe this age of the Earth is going to be their last stronghold. And what's the final gasp of when they're trying to deny God? They're trying to deny the Bible. So 2 Corinthians 10:3-5. For though we walk in the flesh, we do not war according to the flesh. For the weapons of our warfare are not carnal, but mighty in God for pulling down strongholds, casting down arguments and every high thing that exalts itself against the knowledge of God, bringing every thought into captivity to the obedience of Christ. So again, in this case, it's just people looking for ways to discredit God's word, looking for ways to say, basically arguments that's exalting itself against the knowledge of God. Somehow arguments are trying to oppose the Bible. And so also 1 Peter 3:15, because this is maybe the last stronghold, this is an area where you really expect to be persecuted in. They're not going to persecute you for saying, hey, I think I have free will, because they realize everybody that's listening is going to take your side. They're not going to persecute you for saying, hey, I really don't think life can just make itself. Because if people actually start thinking about that, they'll all agree, 99.9%, if they think about it objectively, that, yeah, there is no way life could make itself. So they're not going to get persecuted there. Here's an area that might get persecuted. 1 Peter 3:13-15. And who is he who will harm you if you become followers of what is good? But even if you should suffer for righteousness' sake, you are blessed. Do not be afraid of their threats, nor be troubled, but sanctify the Lord God in your hearts. Always be ready to give a defense to everyone who asks you a reason for the hope that is in you with meekness and fear. Again, talk about the best way to love our neighbors, encourage them to obey the gospel. So many people that might put their faith in the Bible, they'll have a reason that they're not going to objectively consider it. And it's a reason, if they don't let people know about it, we'll talk about it some more during the sermon tomorrow, if they don't let people know about it, they could go through their whole life not objectively considering the gospel because they think there's this one thing they know is wrong with the gospel. And of course, if there's one thing wrong with the gospel, then, how do you know the whole thing isn't wrong? And so this can be an important subject for really just encouraging someone to obey the gospel. First way for them to obey the gospel, they have to objectively consider it. objectively considered isn't going to one page of the Bible, reading a sentence and then going on the internet and seeing who refutes that sentence. It's objectively considered the whole gospel. So Mark 12:29-31, Jesus answered, "The foremost is, Hear, O Israel, the Lord our God is one Lord, and you shall love the Lord your God with all your heart, with all your soul, with all your mind, and with all your strength. The second is this, you shall love your neighbors yourself. There is no other commandment greater than these." Previous session, again, we just talked about true science catching up with the Big Bang. True science catching up with the Bible. So true science is catching up with the Big Bang. It's catching up with the Big Bang, but in a negative way. It's, in other words, it's showing the Big Bang's completely wrong, but it's catching up with the Bible, and we're just becoming more biblically consistent. But what we're going to talk about this session is the age of the earth. So we'll cover, in as much depth as we can get into. But the first one to realize is, if you have different ways you can estimate the age of something. I think everybody's seen an hourglass. That's one way to count time, one way to estimate time. But you have to have certain assumptions on the hourglass. Well, there's analogies for, how could you estimate the age of the earth? And so most of those methods, a lot of people say 85 to 90% of those methods indicate the earth is about 6,000 years old. Or it's consistent with the earth being 6,000 years old. You have sediment on the seafloor, and that's basically, we can measure how fast sediment's being washed into the oceans, how fast it's being removed by plate tectonics. Get a reasonable idea on that. Very consistent with the earth being a few thousand years old, especially when you take into account effects of the flood. It's just completely inconsistent with the 4.54 billion year age estimate and all the assumptions that come after that 4.5 billion years. The bent rock layers. You'll have rock layers. You can go down the bottom of Grand Canyon or other places, and these are they're sedimentary layers. So they have a distinct coloration. They have distinct grain sizes in those layers, and you'll see this layer go on, and it'll just bend. And some of these bends are like 100 feet tall, so you have this bend, and then the same rock layer. Well, that can't happen after the rock is hardened, because some of the theories will say, that rock layer is hundreds of millions of years for that rock layer to form. Well, if that was true, the layers would have hardened, and when it was bent, you would have seen a lot of cracking. And you don't see cracking. There's no evidence of metamorphosis. In other words, there's no evidence that rock was somehow heated up to the point where it was soft. And so it had to be laid down during the flood and then also bent, because the flood, again, a lot of tectonic activity, a lot of very significant physical things happening during the flood. It was not a gentle rainstorm. It was a very violent event. And so this is the best explanation. It'd be almost like if you find a ceramic coffee cup and you say, what happened was someone had made a ceramic bowl, but I needed a coffee cup instead, so I took that ceramic bowl out of the cupboard and they just kind of shaped it into a coffee cup, and now here's my coffee cup. You're like, it doesn't quite work. And it's kind of the same thing. When the layers were soft, you can bend them, you can do whatever you want to with them. When the clay was soft, you could take something that you're on the potter's wheel and you're thinking you want a bowl, and all of a sudden you get a little sleepy and you're like, I really need a coffee cup. And so you make a coffee cup instead. Okay, so, but you can do that when the clay is soft. You can't do it once it's hard. Well, it's the same thing with the bent rock layers. Soft tissues and fossils. So, again, when I was growing up, the reason we would never find soft tissue in fossils is because it can't last. They said, remember my first book, when I was really little, it said 50 million years, when the dinosaurs lived. Now they're like, 68 million years. Soft tissue can't last so long. That is absolutely right. It's surprising for soft tissue even to last a few hundred years, let alone a few thousand years, and no way when you get into the tens of millions of years. And so, but we find it all the time. Now you can take dinosaur bones, you section them, and you find soft tissue in the middle of those bones. And so that's one project I think the church could do. We were brainstorming some last night just around the brotherhood. There's the equipment where we could actually get dinosaur bones that say have been in permafrost, section them, and then try to sequence the ancient DNA. Because we have some of our Fried Hardeman, for example, they have some of the best equipment around, just happens to be very good at sequencing ancient DNA. So just a thought. But it's not just us. I mean, these are secular scientists that were able to report it, back in the, I think it was like 2005 when the reports first started coming out, somewhere in that time frame. But you find soft tissue in fossils. Again, very hard to explain if these fossils are really old. Very consistent with those fossils being formed during the flood, buried during the flood, and then again, just that soft tissue being the last, a little over 4,000 years, 4,500 years or so since the flood. Rapidly decaying magnetic field. The total energy in the Earth's magnetic field is decaying on an exponential, and we can measure back to about 1,000 years, and so we're pretty confident in that. Well, that's really consistent with just, during creation week, that magnetic field was formed, and then it's just decaying on an exponential, and that's how magnetic fields decay. Really hard to explain any other way how our magnetic field could last as long as it has. I mean, if we really were, it can last 20,000 years, up to 20,000 years, very consistent with 6,000 years. But really hard to explain that, maybe somehow it just keeps regenerating itself, or this happens. So come up with some really contorted ways to try to justify why the Earth has a magnetic field. But you say that, that's why we'll have the only magnetic field in the solar system. Well, again, true science advancing, we send in probes to outer planets. Right, and most of the planets have a magnetic field. Moons have magnetic fields. And so again, very consistent with something in creation week causing those magnetic fields that have then just been decaying exponentially ever since. Very hard to explain otherwise. So that's decaying magnetic field. Helium and radioactive rocks. Okay, when you, we'll talk a little more detail on this. When you have something like they call them zircons, and about every 6 months there's some article how these zircons were formed, and they estimate the age of the Earth to be like 1.5 billion years, not the age of the Earth, the age of the zircon to be 1.5 billion years. And you look at how they do it, and in a zircon you have every now and then a few percent of that crystal, it's uranium, and the uranium over time decays into lead. So like uranium-238 decays into lead-206, but you get essentially, there are 8 alpha particles, but an alpha particle is essentially a helium atom. And so there's helium being generated while that uranium is decaying to lead. And so what you can do then is you can say, okay, here's how much uranium decayed to lead, and if you use the current decay rate of uranium, you get one age, and that's typically the 1.5 billion years. But if you look at just how much helium is still in that zircon, you get another age, and you know that zircon can't be more than a few thousand years old because the helium would have diffused out. And I'm not sure when this building was built, but say we'd walked in this morning, there's a helium balloon up on the ceiling, okay? So you look at it, what are you gonna think? We think, well, they must have had a birthday party or something, and the balloon got loose and it's up on the ceiling. And then if someone got up here and told you, no, we had a big party when the building was complete, and someone released a balloon and it's been up there ever since. Okay, you think, and the reason is because helium diffuses out of basically, everything. And so you'd know that the helium would diffuse out of the balloon very, not 30, 40 years ago, or, and so that's the, it had to be very recent. And so so the same thing's true with these zircons. You can send a zircon to a lab, you can measure the diffusion rate, the diffusivity of that zircon. So you have true science, experimental knowledge about how long it should take helium to diffuse out of that zircon. So that's actually what's really measured. And that's where we find that, there's a lot of radioactive decay, but it had to happen very recently. The carbon-14 in fossils, coal, and diamonds, carbon-14, and again, we'll talk about this in more detail, it has a half-life of 5,730 years. And so that means with carbon-14, half of the carbon-14 goes away every 5,730 years. And so we have very good equipment for detecting carbon-14, accelerator mass spectrometers. You can detect it very well, but even with that really good equipment, you figure out that after 90, 100,000 years, there'd be no detectable carbon-14 left, because just every 5,730 years, half of what's remaining is going to go away. And so you just run the numbers, and it's just get to too low a concentration or to be able to detect it. But we see carbon-14 in fossils, coal, and diamonds. I mean, Hope diamond's said to be about 1 billion years old. Coal, sometimes they'll say Pennsylvania coal is 300 million years old. Fossils, supposed to be tens of millions of years old. We still find detectable carbon-14, and especially when you find carbon-14 in a diamond, again, we're very good with our laboratory techniques. We can rule out contamination. We can, diamonds themselves in very tight crystal structure, so you don't get carbon-14 diffusing in and out. You can rule out all the possible explanations, and so that fact that carbon-14 is there shows that, it doesn't give us an exact age. Doesn't say, the Earth is 6,000 and so many years old, but it does rule out the idea that the Earth is millions of years old or billions of years old. So again, very consistent with a few thousand years old, very inconsistent with this idea of a 4.54 billion year old Earth. Very little salt in the sea. That's like the sediment on the seafloor. We can measure how fast salt goes into the sea, how fast it comes back out, and then DNA in ancient bacteria is another one. Just where, and that's, to me, that's almost a two-edged sword, because you see DNA in ancient bacteria, and they'll talk about bacteria. They think they'll say maybe that's hundreds of millions of years old. Well, that DNA shouldn't last that long. So that's one reason we know it's not that old. But what's also interesting is that DNA it's basically the same as DNA in bacteria today. So if someone's believing in evolution, wouldn't there be some change, over hundreds of millions of years? And so it's almost like either way they look at it, it's kind of refuting their theory. So radiometric dating, it's just summary, different isotopes are typically used in radiometric dating depending on the type of sample. Carbon dating, of course, the sample has to have an adequate amount of carbon. And then, so that's usually used if they're trying to say, like, how old is an artifact, like a wooden bowl or, some piece of wood, something that has to contain carbon. And again, it can only be used, just objectively, it can only be used for a certain amount of time, because if half of the carbon-14 is going away every 5,730 years, you don't usually use carbon dating. If someone goes in with that mindset that something's really old, they're not even going to try carbon dating on it, typically. But they can also be based on decay of potassium-40 to argon-40, decay of uranium-238 to lead-206, decay of rubidium-87 to strontium-87, decay of samarium-147 to neodymium-143, other decay chains. So you have a lot of different radioactive decay chains that can be used. And so start out just going to quickly talk about carbon dating. So the way carbon dating essentially works is you have most of the carbon-14 seems to be coming from cosmic rays that interact with the atmosphere. In that interaction, you'll have basically nuclear reactions that cause neutrons to be emitted, and then those neutrons that are emitted, they can be captured by a nitrogen-14, which when a nitrogen-14 captures a neutron, it basically spits out a proton. Okay, so these are, think it's analogous to a chemical reaction, but they're just nuclear reactions. So a neutron getting absorbed in a nitrogen-14, it makes a carbon-14 get formed. And so right now, that happens enough that about 1 out of every 1.2 trillion carbon atoms is a carbon-14. And that's just from this process that's going on in the atmosphere. Well, then, we all are ingesting food. Animals are eating grass, we ingest the animals, or we ingest the vegetables. So right now in our bodies, you'd expect there also to be the same ratio. Say 1 out of every 1.2 trillion carbon atoms would be a carbon-14. In a tree, 1 out of every 1.2 trillion carbon atoms would be a carbon-14. And so that's essentially the basis for carbon dating is, okay, what's going to be this carbon-14 to carbon ratio? And so say right now, that table down there is made out of wood. Probably made pretty recently. So you'd be about 1 out of every 1.2 trillion carbon-14s. 1 out of every 1.2 trillion carbon atoms would be a carbon-14. So if we came back in 5,730 years and the decay rate stayed the same, everything else stayed the same, now you'd be down to 1 out of every 2.4 trillion. It's half the amount. And then you'd be 1 out of every 4.8. Then you'd be 1 out of every 7.2 as you keep going in your half-life. So I think on the next slide here, I just rounded it down to, you basically didn't do any rounding on this one. But again, this is just the way the numbers work out is if we came back in 5,730 years, you'd be 50% of the original concentration, 11,460 years, down to 25%, 17,190 years down to 12.5%. So that's kind of the basis of carbon dating, and we can see how that would work going forward, okay? Because we can measure what that carbon-14 to carbon ratio is today, and we can go forward with it. But you can't go backwards, okay? Because we don't know what that carbon-14 to carbon ratio was in the past. We only know what it would be in the future. And so I had some more math. Maybe I'll go back to that in a minute. But basically, what you have is the main discussion point, just moving quickly, is the carbon-14 to carbon ratio around the time of the flood could have been significantly different than what we see today. I'm sorry, I actually did scare you with the equation. Let me go ahead a little bit. Okay. And that's because we estimate that there's 200 times more carbon buried in coal and oil and natural gas than there is currently in the biosphere. And so that carbon if it was in the biosphere before the flood, if we're assuming most of the coal was based on matter that was buried during the flood, well, our ratio could be off by a factor of 200. In other words, our assumption for an artifact that's made shortly after the flood, when that tree grew up, or that, whatever was used to, say, make a wooden bowl, well, the carbon that was used to make that wooden bowl, it could have a much lower carbon-14 to carbon ratio than wood does today. And the reason it could is because you have all the effects of the flood. You not only have all of this biomass being buried during the flood, which contains a lot of carbon, you also have the oceans warming up. When the oceans warm up, they release CO2. Depending on the carbon-14 to carbon ratio in that CO2, that can have a huge effect on the carbon-14 to carbon ratio in the atmosphere. And so you have all these different factors. There's even mentioned, we talked a lot about the Smithsonian museums. Even in their exhibits, they talk about CO2 concentrations more than an order of magnitude higher than we see today. They'll say in the distant past, but that could have been events associated with the flood. So what that does is it can really skew your age estimate, because if that carbon-14 to carbon ratio is lower than it is today, but we assume, as the Bible says, people will do that. Everything's been always been the same. Remember, it says they forget about the flood, they forget about the creation, right? And so if we forget about the flood, forget about the creation, we assume that carbon-14 to carbon ratio is the same, always has been today, roughly the same, then we're going to get wrong estimates, and you can be way off. And so I guess just because math is a lot of fun, I'll go back and do, we'll just do the math really quick here. Okay, so this is your, let's see if I can get back to it. Okay, so this is your basic equation that's used in carbon dating. The only reason I'll mention this is because it's very mathematical. The equations themselves are very mathematical, and it's just the concentration that we see in a sample. Say we get a wooden sample today. Well, that's equals, it's going to be the carbon-14 concentration of the sample at death, and then e to the negative lambda t. T is just time, lambda is 0.6931 divided by the carbon-14 half-life, e is the base natural logarithms, and then of course you have concentration at death, and then the equation is usually written like you see at the bottom, where c equals c0 e to the negative lambda t. Okay, so suppose we see a sample that has 2% of the current atmospheric concentration. So instead of 1 in 1.2 trillion, you're now 1 in 60 trillion. Okay, so it's only 2% of the concentration that we see today. Well, how old is the sample? Well, if I plug it into my equation, c equals c0 e to the negative lambda t, but I assume constant decay rate, may or may not be true, but that's one assumption we can make. So that's one assumption, but the other assumption would be, what do I assume for C0? Okay, well, let me try, I'll just assume that the carbon-14 to carbon ratio when that sample was formed, same as it is today. Uniformitarian, all things remain the same. And so don't take into account the flood, don't take into account recent creation. So if I make that assumption, which is unfortunately the typical atheistic assumption, well, this is what I come up with. And again, you're just running the numbers. So you run through that equation. You say, well, yeah, that wooden bowl was made 32,330 years ago. And unfortunately, you'll hear people claiming that. Oh, well, I dated this bowl myself. This wooden bowl is 30,000 years ago. And boy, it's really fascinating. Ooh, oh, wow, what would things been like 30,000 years ago? But obviously, that's non-biblical. That's not a biblical age. Okay, but that's, again, ignoring effects of the flood, ignoring recent creation, using very reasonable effects. So in other words, say I assume that could be, again, a 200th, 1/200th the concentration wouldn't be unreasonable. Let's say I assume it's, maybe I say it's was 30%. I'm sorry, 1/30th. So the atmospheric concentration around the time of the flood was 1/30th. Same equation, same numbers. I say that wooden bowl is 4,210 years old. Again, it's all depending on my assumption. I'm not saying it really would be, but it's a very biblically consistent number, and it'd be consistent with, hey, that artifact was made in a civilization, one of the civilizations that arose very quickly after the Tower of Babel. So the key on carbon dating, it's the assumptions that are made. Because I've heard some, actually people that, you consider very, they believe the Bible, but they'll say, oh, but I just read that, we can, age of carbon dating, we know it now to within, I think one person told me 1%. But you push them on this, you can't know it within 1% because it's very assumption dependent. I mean, there's ways you can infer it, But it really comes down to, if you make biblically consistent assumptions, you'll get biblically consistent answers. If you assume the Bible is wrong, make assumptions based on the Bible being wrong, well, you'll get biblically inconsistent answers. And so, when he was saying the 1%, pushed him a little bit on it, he admitted it was just, we can measure the carbon-14 to carbon ratio to easily within 100%. So if we were to go on an accelerator mass spectrometer, yeah, we can measure that ratio to within 1% easily, because we have really good laboratory equipment now. But that's got nothing to do with the age that's calculated. The age is literally, do you take into account the effects that God told us happened, or do you ignore them? And so that's the key difference. So, okay, so again, talked about how you have carbon-14 in coal and diamonds, how much carbon-14 was in the earth, how was it distributed, what if radioactive decays were accelerated in the past. That's what we'll talk about some next. That's more for the other methods. We'll be talking about that. Cosmic ray flux or spectrum different in the past. You know, notice I mentioned carbon-14 is made by cosmic rays hitting the Earth's atmosphere. We know the strength of the Earth's magnetic field is dropping. As if the Earth had a stronger magnetic field in the past, you'd have less cosmic rays hitting the atmosphere because it repels the cosmic rays. You'd have less carbon-14. The samples appear older. So it's all, you start looking at all these assumptions we're making, and again, just it's really important that we just look at the scientific data, and of course we try to take into account effects of the recent creation and the flood, and then also just the idea that have a lot of evidence that coal was recently created during the flood. I mean, you have trees that go through coal seams. I mean, they seem vertically through coal seams. That seems like, oh, whatever. Well, that's actually huge, because how does a tree get vertically in a coal seam unless it's all forming very quickly, which would be consistent with the flood. And then, just other effects you might have. And so I think the last one, kind of technical, we'll talk about on the carbon dating is people will say, oh, well, when we say an artifact is so old, usually you don't use carbon dating. Usually you're looking at, for example, say it's a pottery, you look at pottery styles, what layer, how deep was that pottery found, patina, which is basically residue on the pottery, and so that's how we're dating it. So they'll say that's how this is dated. But all of those are ultimately related to carbon dating, or they're based on carbon dating. They're calibrated to carbon dating. So, for example, if you just find a piece of pottery buried 20 feet deep with a certain style, and that's the only information you had, well, you can't estimate an age from that. And so what they ultimately end up doing is you try to find that same pottery style about that same layer, but have something containing carbon, so you can do carbon dating on it. And then from that carbon dating, you estimate the age of that pottery, but then anywhere in the world you find pottery, say at about that depth with that amount of residue, that style, you say, oh, okay, yeah, we know when that was popular, or when that was, happening. And so they give a certain date, but that date's based on the carbon dating. And if the carbon dating's wrong, those estimates will also be wrong. So let me give you an example. Okay, so here's a remote, okay? And so I send this remote off to a laboratory and say, how long is this remote? I've just been curious, how long is it? They come back and say, oh, it's 100 feet long. Okay, that's cool. So I have this remote and it's 100 feet long. And so now I say, wow, okay, I wonder how big my laptop is. But I don't, rather than sending my laptop out to the laboratory, I say, okay, my laptop, let's see, there's 100 feet, 200 feet. My laptop's about 300 feet across, okay? So now I know my laptop's 300 feet across. So I say, well, I wonder how big this podium is. And so I say, well, okay, let's see, it's about 1.5 laptops wide, so that would put me right at 450 feet. Okay, so I've got a 450-foot wide podium here. You got, good equipment. And so then I say, I wonder how far across is the stage. And so take the podium, I won't do it, but take the podium and go across the stage. And it's 12 podiums wide, you got 12 times 450, so you got, 6,000 foot wide podium here. That's something, I mean, it's, not quite 6,000, no, we'll call it a mile. We'll call it a mile even, okay? So your stage up here, it's a mile across. So now I go back and I tell people, oh man, I got to give a presentation to this congregation. You won't believe it. Their stage is a mile across, okay? And fantastic, down in Texas. Now, Texas people expect that, but you say, okay, Texas fan, it's a mile across. And they'd say, well, how do you use that? Did you use that remote to estimate that distance? And I'd say, no, didn't use the remote. I used the podium. I knew the podium was about 450 feet, and I just, and I just used the podium to measure. I didn't use the remote. And I said, well, okay, because I'd heard some questions about they're measuring how long a remote is, but if you use the podium, then yeah, you're probably right. Man, that's impressive, but see, the whole problem is this podium that I was using to measure the distance across, it was all based on the remote. Okay, and so that's what's happening when we say, archaeology or this or that. Somehow it's consistent with carbon dating. Well, of course it is, because it's ultimately calibrated on carbon dating. And even tree ring dating, at some point they have to go to carbon dating to try to make that happen. Plus, trees are going to be growing a whole lot different in the post-flood climate than they are today. So that's the other issue on tree rings. And then the final thing is you look at these ancient records, and most ancient records, they're really consistent with the Bible. We won't get to talk about it this weekend, but you just look at the flood legends and some other things, really consistent with the Bible. And so usually the ancient records are consistent with the Bible, but if they're not, again, who do we believe? Well, many good reasons to believe the Bible and not some of those other ancient records. Okay, so now moving into the other dating methods, because we just have a few minutes, but it's also really important to talk about let's see, I guess I'll go back one, the other dating methods. Okay, so I talked about, again, if someone says a piece of pottery is 30,000 years old, well, that you can pretty much just say, okay, they probably used uniformitarian assumptions that didn't account for the flood, and so you can understand why that's going to be off, and that's probably why it's off, because you go back 2,000 years, 3,000 years, carbon dating is actually pretty accurate, because you're long enough after the flood that you don't have this, there's not a big difference between biblical assumptions and uniformitarian assumptions, because everything's settled out after the flood. The last flood was the last really catastrophic event. So, if someone says, oh yeah, I did radiocarbon dating, and I think that artifact's from 500 BC, I probably believe them, because everything had settled out after the flood. It's only when you get back to the earliest civilizations, really close to the flood, that you expect this big difference between carbon dating and based on the assumptions, which again, if you assume the Bible's wrong, plug in those assumptions, you're going to get biblically inconsistent dates. Now, if you make reasonable assumptions based on the Bible, you'll get biblically consistent dates. So that's pretty straightforward. Now, for other methods, you wonder, well, how do they come up with this idea that the Earth's 4.54 billion years old? Again, it's radiometric dating, but they have to make assumptions also. And so the three assumptions you'll generally hear about, you have the degree to which radioactive decay rates have fluctuated through the life of the sample being dated. In other words, have there been fluctuations, have those decay rates changed? Original concentration of isotopes used to date the sample, it's kind of the same thing. What was the original ratio of these isotopes in the sample? And then has there been any addition or subtraction, throughout the time frame of the sample since that sample formed? So those are three assumptions. And so again, just going to look at one of those assumptions today. And if you look at the effects, changes in decay rates during creation week and or the flood, they could have a very significant effect on the estimated ages. And so that was, kind of talked about, but it really didn't start gaining, I guess you'd say, I'll call it credibility. It's been talked about since the 80s. And this is in the secular literature. This isn't just, Christians have thought of it. But it's really in the secular literature. It was about 2006 when it really started being reported that we see fluctuations in radioactive decay rates. And so when I was growing up, when I was going through physics, that was one of those ones, but we don't know why, but radioactive decay rates, they just don't change. They're just completely constant, so that's the assumption. That's the assumption that goes into all these radiometric dating methods. But we started seeing fluctuations occurring, and it started to get very well publicized. And this was pretty much Stanford and Purdue started out. It was a professor emeritus at Stanford of physics that started to really publicize it. And we were talking about, well, why weren't other people talking about? Well, literally, this is so, you're basically saying that something that we've assumed to be true, to almost like a law of physics for the last century or more, we're finding out is false. You have to have a pretty high stature to, anybody can say it, but to get it to actually stick and people take it seriously, you have to have pretty high stature. And so he proposed it. He unfortunately passed away last year. I think he lived about 100 years old. Really worked on radar in World War II. Brilliant guy. But anyway, give some quotes from him in a minute. But so now the point is, okay, today things are pretty stable. We'll have storms and have earthquakes, but we still see these small fluctuations in decay rates. Even though things are physically stable, the universe is physically stable, we see these decay rates fluctuating. And so basically the idea is, okay, what if those decay rates were fluctuating a lot more during creation week or the flood? In other words, we see fluctuations today, so we know they can happen. We really don't understand why. We're still trying to figure that out. So again, we're back in 1907 thinking there's civilizations on Mars. Right now, we're thinking, okay, wow, we just noticed that these decay rates are fluctuating. We have no idea why yet. There's a lot of ideas out there. So again, it could be a long time before this gets resolved. Hopefully it won't be. But the whole point is, okay, if we see changes now, could those changes have been a lot bigger during creation week and the flood? And of course, obviously yes, and if you want to tie it back to the physical, because those were not only miraculous events, but just physically, incredible events. If you're just talking about what all was happening. And so that would fully explain, if that was true, could fully explain the potential discrepancies. Now it's both between radiometric dating and the biblical account, but it's also the discrepancy between radiometric dating and all these other methods we have for estimating the age of the Earth. And so that's important. You have all these estimates for estimating the age of the Earth. They contradict radiometric dating with the current assumptions. And so it'd be two things. Again, you can look at, biblically, we know the Earth's on the order of 6,000 years. See, people say less than 10,000 years, and that's not, to me, that's not the argument. It's thousands of years. But this, if there were fluctuations, that would explain the discrepancy, not only between the radiometric dating in the Bible, but also the radiometric dating and all these other, very reasonable methods we have for estimating the age of the Earth. And so just to give some of the quotes, this was Popular Science back in 2010. Says the sun at 93 million miles away appears to be influencing the decay of radioactive elements inside the Earth. Researchers say. A study by Stanford and Purdue scientists found that the core of the sun, where nuclear reactions produce neutrinos, spins more slowly than the surface. This phenomenon might explain changing rates of radioactive decay scientists observed at two separate labs, but it does not explain why the decay change happens. That violates the laws of physics as we know them. The article asks, how could the nebulous neutrino, which does not interact with normal matter, be affecting decay rates? No one knows. It might be a previously unknown particle instead. And so it's actually, again, if someone's really just into science, that's really exciting when someone says, hey, we made this observation and we verified it, it looks credible, and oh, by the way, this is pretty strong, violates the laws of physics as we know them. Well, that's actually exciting because that's going to be an area that you might be able to advance in, might be able to learn more in. And so anyway, that was a quote from 2010. 2016, now these were a lot of, Stanford University, again, very credible university, a lot of their, on their website, a lot of the things published from that university, says the research that Sturrock learned about in Tucson concerned fluctuations in the rate of decay of radioactive elements. The fluctuations were highly controversial at the time because it had been thought that the decay rate of any radioactive element was constant. And typically, most places you look, it's still going to say that they're constant, just because they haven't updated yet. And then Sturrock decided to study these experimental results using analytical techniques that he and Scargill had developed in the study. And now that I just read it to you, that's you can read. So that's the. But again, just talking about just some of the research that was going on there. Then goes on, says in examining this was 2016. Also says in examining the radioactive decay fluctuations, the team found evidence that those fluctuations matched patterns they had found in the super Kamiokande neutrino data, each indicating a 1-month oscillation attributable to solar rotation. The likely conclusion is that neutrinos from the sun are directly affecting beta decays. This connection has been theorized by other researchers dating back 25 years, but the Sturrock, Fishbach, Scargill analysis adds the strongest evidence yet. If this relationship holds, a revolution in neutrino research could be underway. Now this is exciting because, we can make an observation. If no one cares, you're not going to get funding. You're not going to be able to pursue it. And they're saying, hey, there's at least some applicability here. There's some interest in this. And then last quote I'll read, this was Astroparticle Physics. It says, additional experimental evidence is presented in support of the recent hypothesis that a possible solar influence could explain fluctuations observed in the measured decay rates of some isotopes. These data were obtained during routine weekly calibrations of an instrument used for radiological safety at the Ohio State University research reactor using chlorine-36. The detector system used was based on a Geiger-Muller Geiger-Muller gas detector, which is a robust detector system with very low susceptibility to environmental changes. A clear annual variation is evident in the data with a maximum relative count rate observed in January, February, and a minimum relative count rate observed in July, August. You know, January and February, that's when the Earth's closest to the sun. July and August is when we're furthest from the sun, because our orbit's not perfectly circular, it's elliptical. And that's 7 successive years, from July 2005 to June 2011. The annual variation is not likely to have arisen from changes in the terrestrial surroundings as we show here. So again, published, peer-reviewed. Yeah, this is happening. Also now getting data, changing radioactive decay rates, Brookhaven National Laboratory, Federal Physical and Technical Institute in Germany, and it's interesting also both alpha and beta emitters are showing the changes. So, okay, so that one assumption, we know they're not constant. Now the question is just, could it be changing enough? Could the changes have been enough to affect our radioactive dating method? So I'm going to give a couple of charts to start with, and try to wrap up here again in a few minutes. So the first one you notice, the first evidence is what they call discordance between estimated ages. And so this is a chart, it's out of, say, a typical earth science textbook, maybe 8th grader might be reading it, maybe some higher grades. And what this is basically showing is they can find rocks at the bottom of the Grand Canyon. As you know, like carbon dating, you have to have carbon in the sample to be able to do carbon dating. Well, for these other radiometric dating methods, you have to have the specific isotopes available to do the dating method. Well, there's rocks at the bottom of the Grand Canyon. It's the bromine phibolites at the bottom of the Grand Canyon. Some of them actually contain like 3 different ways to date them, which is impressive. So they have 3 different radioisotope chains for dating. So this is a rock. You had upper left is uranium-238, and that's they used the uranium lead method, and they had 1,883 million years plus or minus 53 million years. Okay, so that's the age there. Then lower down to the right, you have a rubidium strontium. Okay, that was 1,240 million years plus or minus 84 million years. And then you go up and to the right, as a samarium neodymium, you had 1,655 years plus or minus 40 million years. Okay, so you're an 8th grader, you're just kind of in and out of class, if you know what I mean. I mean, you're physically there the whole time, mentally, yeah. And so you see this chart. Well, what's the impression you're going to get? Wow, we know that rock's really old because they have 3 different dating methods, and they're all saying it's more than 1 billion years old. And for an 8th, I mean, that'd be the impression you'd make. So we've firmly shown that rock's more than 1 billion years old. But you might have wondered, why is he mentioning the error bars? Well, it's the error bars that we actually need to focus in on, because the error bars don't overlap. So what's really important about that chart isn't that, oh, they're all over 1 billion years. What's really important to note is, hey, at least 2 of those 3 have to be wrong. Okay, just think of it, let that sink in. You got 3 independent dating methods. They all disagree. 2 of the 3 have to be wrong. All 3 could be wrong. I mean, it's not, and that could actually be, if all the assumptions are made in interpreting those dates, that's probably, the more reasonable one is if 2 of the 3 are wrong, and I'm basically using the same techniques, all 3 should be wrong, or could be wrong. So I'll go back to my remote. So, okay, we established that this is 100 feet long, the first lab. We'll say, they said, hey, what is the error bar in that? So it's a foot. Okay, so this is 100 feet long plus or minus a foot. Okay, so I say, man, I don't know if that's really 100 feet long, so I send it off to another lab. And they come back and they say, no, it's 200 feet long plus or minus 2 feet. And I'm still like, I'm still not sure. So I send it up to another lab. They say it's 300 feet long plus or minus 3 feet. Okay? So I'm like, well, got 3 independent measurements, not sure which one's right. So the only thing I know for sure is that it's over 100 feet long, because they're all 300 feet or more. Okay, that would be an assumption. But what I should really go back to the labs and say, okay, what were some of the assumptions? How are you measuring that? How did you come up with those links? Because again, you shouldn't have that kind of disparity. That's what we see, and that's when they call discordances. And so that's evidence that there's something something we're doing wrong. And in this case, it would be, possibly the changes in radioactive decay rate that are giving us those long estimates. And then what's interesting, okay, so if you get enough of this data, well, you could actually start saying, okay, this is where you mentioned, technology can be used for good or bad. Well, it'd be fun to, if you could actually get raw data, which a lot of it gets suppressed or not reported, just get raw data on as many samples as you can. And you'll notice some of those are alpha emitters, some of those are beta emitters. There's differences in atomic masses, there's differences in atomic numbers. If you ran all that data together, you might actually be able to figure out what's causing those decay rates to change. Based on the Bible, roughly how long it was, and so what would have to be the changes in the radioactive decay rates to match all of this data. And that would be something that it'd be impossible to get funding for, frankly, in a secular nation, because you're basically basing it on what the Bible says. But if someone could somehow pull that off, boy, you could learn so much that would apply, again, not just physically, but also, again, helping people objectively consider the Bible. But not saying that's feasible now, but that'd be just some project, another project to look at. The other one that we mentioned was this helium and zircons. And so a group did this, again, they're all PhDs. You don't have to have a PhD to think about stuff like this, but they just put together a team of PhDs, and they got some samples, and this was the helium retention in the zircons. And so this was the case, again, where you have helium in zircon crystals. You can measure how fast that helium leaves zircon crystals. And so what's great is now you have two ways to estimate the age of that zircon crystal. One is how much uranium turned into lead, because you can say you assume that there was no lead in that sample to start with. It's an assumption, but okay. So there's no lead in that sample to start with. We see that this fraction of uranium turned into lead. How long would that take? Okay, so that's a straightforward calculation. But you can also say, okay, how much helium is left in that zircon? Gone to the lab, we measure how fast helium diffuses out of zircons. How long would that take? And so what the group did is they have what they call the creation model. And basically I was just saying that assume that all that decay had to happen over the last 6,000 years, because that's the age of the Earth. So they say, okay, that's how long it had to happen in the last 6,000 years. And then you had the uniformitarian model that would say, oh no, it could have taken the age of the Earth, or billions of years to decay. So the data, that's the dark, large dark dots that you see on top where it says data, and you see how those are the dots that are circled in. And then the models themselves, those are the squares that are clear in the center. So the creation model is on top, and it matches the data extremely well. So this is measured data, but it's assuming you had a lot of radioactive decay, but it happened recently. Now they published the model before they got the results back. And that, to me, that's really gutsy, but that's a real scientist is saying, yeah, I'm pretty confident in this, so I'm going to go ahead and publish my model before we have the data back. Data comes back and it matches the model basically dead on. The uniformitarian model, that's the idea that all that decay took place over the last few billion years. It's off by a factor of 100,000, and that's huge, especially since this is exponential. And again, what they were just measuring was based on the measured diffusivity of these zircons at various temperatures. Okay, so again, really powerful evidence against this idea that the decay rates have always been constant. And again, but like the Big Bang, I think at this point they're still at the stage of just trying to ignore this kind of data. Big Bang was kind of at that stage in the 60s. It wasn't until the 70s where they finally admitted, hey, we got to make up some things to make this work still. But again, it's all the data is, again, true science is starting to catch up with the Bible. Now, people talk about, some of the immediate ones, if you accelerate radioactive decay rates, wouldn't that melt the Earth, if they accelerated this fast? Because you get a lot of energy during radioactive decay. Well, it depends on how they're accelerated. So this is another huge clue. We don't think the Earth melted again. So, what effect would stretching out the heavens have? That goes back to 17 times in the Bible, God talks about basically stretching out space. So a lot of people hypothesize what they think might happen there, but we don't really know. I mean, that's beyond our physics understanding. And so so that's another clue. We know the Earth didn't remelt. So what could stretching out space entail? So I'm going to go ahead. I'll go through about 5 more slides just to wrap up this particular section. This is really fascinating. I guess the main one is we know there's ways to accelerate radioactive decay. Some of these are fairly extreme conditions, but this was a factor of 10,000 with thorium-228, just with ultrasonic cavitation. We know we've seen the effects of cavitation. This was the Glen River Dam or Glen Canyon Dam. Again, just tore the dam up really fast. This was just a few minutes, and it just started to get some cavitation. It actually caused us to redesign all of our dams because it almost came very close to failing that dam, which would have been catastrophic. And then you can also look at other things that you see with radiometric dating. We mentioned didn't mention potassium argon yet. That's usually used to date volcanoes. And so it's so known to be inaccurate. It's often used to it's almost like humorous, and so these wrong dates that they attain, they're humorous, but they're still damaging. And so this is a museum down in New Zealand, and they had a 1954 AD eruption. It's Mount Arahu, and they keep telling me how to pronounce it, and I always pronounce it wrong. But that's how it's spelled in New Zealand, and it said potassium argon aged as high as 3.5 million years from something that they knew erupted in 1954. So this is in the museum, and it's almost like, oh, that's kind of cute. That's funny. 3.5 million years, but we saw it erupt, 70 years ago. So, but then literally like 3 exhibits down, they have this really great displays in the museum, and it talks about this volcano that erupted 550,000 years ago. And I think it even, of course, artists, they have like these primitive-looking plants and things around that volcano before it erupts. Well, you just told me that your dating method can be off by 3.5 million years. So then if you tell me that this is 550,000 years, you think about it, you're like, it could have been 200 years ago and no one just wrote it down. You don't know, because that would have still fit in that dating method. But you had all the artists concept. So again, you go back to someone's not really thinking, they're just enjoying the museum. Not enjoying the museum and thinking some, but not really questioning things. They'll look at that and say, oh, 550,000 years ago, okay, well, that shows the Bible's wrong. That goes against the Bible. And so again, it's humorous, but it can still do damage. So just summary on radiometric dating, significant evidence against typical uniformitarian assumptions. We see measuring fluctuations in radioactive decay rates now. We see carbon-14 in coal and diamonds. We see discordances in age estimates based on radioactive decay. We see significant heliums and zircons. See significant errors dating rocks of known age. And so, one way to tie that all together, and again with all the other methods for estimating the age of the Earth, is just realize accelerated radioactive decay during creation, weakening, and flood, it can actually explain all those discrepancies, and they also give us a lot more information, because we could probably know just how those discrepancies, how or why those discrepancies occurred. And so, again, just finishing up with a couple scriptures. True science, the Christian's friend, 1 Corinthians 10:13. No temptation has overtaken you except something common to mankind, and God is faithful, so he will not allow you to be tempted beyond what you are able, but with the temptation will provide the way of escape also, so that you'll be able to endure it. I think the temptation here is to just compromise. 1907, Wall Street Journal's plunked down in front of you. The temptation to just say, okay, well, maybe there's a civilization on Mars. Just compromise, don't think through the biblical stuff. It's a real temptation. A lot of times we're just tired. It's not actively trying to do something wrong. It's just, we're just tired, so we complicate. So compromise. So on this time, you might get a lot of persecution. But just resist that temptation. Don't compromise. Don't grow weary. 1 Timothy 6:20-21. O Timothy, guard what has been entrusted to you, avoiding worldly and empty chatter, and opposing arguments of what is falsely called knowledge, which some have professed and thus gone astray from the faith. Grace be with you. So again, just avoid this kind of empty chatter, opposing arguments, saying, well, the Bible, it's great. It's like 95% right. Don't go along with that. No, the Bible is 100% God's inerrant word. And so kind of empty chatter and opposing arguments. So with that, I think might have some instructions for lunch, and I'll let Robert come up and let us know. And look forward to the questions and answers. Really appreciate your attention. Appreciate you coming out.
Thank you so much, Mike, for effectively eradicating the so-called science out there regarding how the world came into existence, and like the Big Bang and the age of the Earth. And so we appreciate that so much, how the observable true science really is consistent with the biblical record there in creation and in the flood and so forth. And we appreciate you bringing that together for us today. And I appreciate your courage and your boldness to stand with the scriptures in regard to the age of the Earth and those kind of things, because I know a lot of so-called scientists would laugh at what the Bible has to say, and we might be persecuted for it, but we will always be rewarded for standing with the Lord. So thank you so much for that presentation today. We do have lunch ready for you, and so as you go out, there's bathrooms for the ladies on the left and guys on the right, and you go straight on across into our annex building there, and you'll be served there shortly. And my dear brother Tommy Hicks is here with us today. He's out in the south side in Lubbock, where he's been preaching for a number of years. He was over here at Hanley on the east side of town. Many of you probably remember the Hanley congregation there. But it was great to meet and get to know Tommy way back in the 80s. And it's good to have a friend and a fellow preacher, and we're so glad that he's here with us today. I've asked him to lead us in a closing prayer. And Tommy, if I could ask you to please remember our food today in that prayer. We'll give thanks to God for that. And then after our prayer, we'll be dismissed. So Tommy, if you'll come on.
Would you bow with me, please? Our Father in heaven, we're grateful unto Thee for the privileges that we have as Thy children. We're thankful for our brethren, such as Brother Houts, who is able, with his knowledge and talent, to present the proofs of the things that are so in the Scriptures. We're thankful for this congregation for hosting this event. And Father, we're also thankful for the food that we're about to eat. We pray these things realizing that it's in Thee that we live and move and have our very being. And Father, we know that we're not as we would be if we were perfect. We realize our shortcomings and our sins. And we ask Thee to forgive us of those things as we repent of them that have been done which are wrong. These things we pray in Christ's name. Amen.